Yo, what's up? I'm going to be showing you how to use my Undertale engine for your Undertale fan games and stuff. There's probably going to be some timestamps on the screen right about now. I think I would recommend watching through the entire video, especially if you're maybe new to Godot, but it's entirely up to you. Me personally, I kind of look through stuff. I kind of like to look through videos and just kind of skip around and I'll eventually figure my way out somehow. So if you're like me, just go ahead and do that. But otherwise I would watch it. But so the first part, why choose this engine over other people's engines? Which I guess first to say here is choose whatever engine you're most comfortable with and choose the engine that suits your project the best. And this kind of goes with, I mean, not just Undertale engine like in Godot, but I mean Click Team and Godot and Game Maker. I guess like Create Your Frisk and all that kind of stuff. I'm sure there's some Love 2D engines out there, or even Scratch. But yeah, use whatever is gonna suit your game the best you think, or that you're most familiar with. But I will say Godot is like a really powerful engine that I am very glad I switched to, being a previously a Click Team user. It was not great, and I I'm glad I switched. But why choose this engine? First, I would say a little over 4 years of like making Undertale engine stuff and Undertale games, so that definitely helps give me like some insight on like what to add and what not to add for this engine. And that's pretty much what I did. Is all of my experience with every engine I've worked with in the past. I've pretty much just taken all that information and basically put it into this one game, trying to make it, or not one game, one engine, trying to make it as optimized and just, I guess, feature rich and good as possible without being too convoluted or, just confusing for somebody that's starting to get into it. Like I was back then when I was getting into Undertale games at first. I struggled a lot for a long time trying to figure my way around like engines and stuff. So hopefully this will be for you if you're kind of going doing the same thing. I guess the second part is that this was also made for long-term projects and or not made specifically for, but it has flexibility for. You'll see sooner stuff like this, and I don't. There's an example of the overworld that does it that I'll probably show later in a different video, but yeah. Yeah, and then yeah, like I said earlier, Godot's a powerful free game engine. So, but yeah, I guess I'm just gonna get into it. So basically, so number two, organization, file paths, and where to store new stuff to keep the kind of organization template I have. Uh, so the engine folder basically has the all of the scripts and scenes necessary, or not necessary, but that are used for the engine. So in the battle here, I won't cover the overworld. Actually, no, I won't cover the overworld here. So yeah, you see it has attacks, border, and border's just, let me get rid of this really quick. Border's just this. Um, Camera, dialog box, enemies, engine, menu item, soul. So that's all the core stuff. I guess same with here. Um, Anything that I guess is unique is put in this unique folder. So any enemies that are going to be used throughout the game, um, and multiple scenes or whatever, they're all going to be put here. Same with the overworld. This just has the test scene. There's a very basic game over here. Yeah, and enemies would go into enemies, and then this is just an example. And then attacks. You'll see the attacks work a little differently for in battle, but so that's what. Let me see. That's what this is right here. These are player attacks. That, so for example, the slash that goes like right here or whatever, or like when you use the frying pan or the ballet shoes or any of that kind of stuff. That's basically what this is. Enemies, yeah. So these are just enemy attacks that you want to use. So attack 0 and healing, you'd probably want to put it in a subfolder. And then all the bullets that are used throughout the entire game, pretty much. So that's what's in here. And enemies, shaders just has all the necessary shaders to run the engine and some additional ones like skew, which is nice. And I guess the dust as well, but that's included in the engine. Sprites, let's see. Yeah, this is also pretty straightforward. There's a miscellaneous folder and then everything that's used in the engine. I decided for the battle part to put enemies just into engine and battle. All the core assets like buttons and stuff are in the core folder. Same with flee, some of the soul stuff, and this random dust thing. Yeah, and then there's bullets and the strike in here. So that's where all those basic assets are. Let me delete this. I don't need that. These are basically all the fonts that are used. I'm sure you could probably organize it a little better if you start adding more fonts, but this is just the pretty basic format. Auto load is anything that, or actually pretty much just everything that loads into the game whenever you start a scene. So if I just press F6 and I go into the game, all of these will be loaded. So that includes audio handler, border, global, and utility, which I'll cover later. Audio is also pretty straightforward. All the blitter stuff is in a folder or blitter is like basically just the sounds when people talk. Engine is everything that's used in the engine, and then misc is just any miscellaneous stuff that you want to use in your games that might be useful. One of the biggest problems I had with using past engines was that I had to import all of this stuff manually, but this makes it so that you don't have to, which is very good. Yeah, and then I guess we'll go to the next part, which is the border. Okay, yeah, so border, this is the border node. It's a 9-patch rec that you could just pretty much resize and do whatever you want with. So I guess there's a few things that I'll go ahead and look through the script and I'll basically explain the code. So first, starting with speed, basically the border kind of works linearly, similar to Undertale. So whenever it resizes, it'll just go like in a linear form, like this or something. But the speed determines how fast that is. Manual override is if you want to like tween the position and the size. Yeah, so manually controlled through code, or if you want to offset it, you'd have to make this true. Otherwise, it's going to do it itself in the process function, which is below. New position, new size, these are all just engine stuff, or I guess border variables that you don't really need to worry about. So, okay, these are actually very important. So for attacks, you can use all of these variables for calling the it basically just makes calculations for you so that you can just go border.left and then just get the left side from the attack script. So these are just really nice utility variables. Distance is basically the X and the Y distance from the sides of the border. So yeah, hopefully that's pretty straightforward. The to function is pretty straightforward. It basically takes a position and a size, and it does that linear lerping to the new position. And it just sets the new position and size in here. And this is, so basically the two, you can see right here, it's formatted this. So if I go, like say, yeah, if I just do null, null, and then null, null, this basically says go to the regular position. I mean, you could even write this as null, and then this will basically say go to the regular position, which is this, the position it is now. And then if you put null here, it says go to the regular size, which is this right here. If you don't put null, you can put your custom values, so you can set it to something like this. So for example, it would just be like, it goes X and Y. So if you want to put it in the middle, center of the screen, it would just be that. And then for size, let's say you just wanted to make it 200 by 200. That's how you do it. And then, I mean, if you wanted to keep, yeah, let's say you wanted to make the size the regular like distance right here. You just put null here because this is the Y value of the size. And if it's null, it's just going to go back to the default. And that's basically what the to function does. It's hopefully pretty straightforward as well. Toggle attack render. This one's kind of interesting when it comes to, I guess it's just kind of it's like an optional thing that you can use that you don't really need to mess with. What it does is it messes with the masking of the, well, so the mask, okay, let me take a step back. This is the back buffer copy, which basically stores all of the bullets, and the masking, which the masking is, let's just go ahead and, the masking is all of this around the border. So the bullets don't like clip through. You can't like see them outside of it. What this toggle attack render function does is it basically puts the bullets outside, the bullets and the masking, this entire back buffer copy. Oh my god, back buffer copy takes this entire thing and puts it outside of the border. Which the reason why you do that is because when you move the border, for example, I will just put a sprite here of the Godot icon. Put it right here. So if you move the border, it's obviously going to move with it. But once the back buffer copy's outside of it, you move the border and that doesn't move. So that's basically what that's for. Just pretty much allows you to either have the bullets move with the box or without it. I think normally it's set to move just independent, I want to say, so it doesn't move with the border. But if that's not the case, you can always just set this through the attack script. So the entire process function is also pretty simple. So it just basically says if you're not manually overriding it, it basically calculates the size and the position. I don't need that. Calculates the size and position based on calculate diff, which is in the utility function, which I'll get into later. But this basically is for the linear interpolation of the border. So yeah, the position and the size is set to the calculated position and size based on the new size and position, which is set with the to function. And the pivot offset is also set, meaning the pivot is always going to be in the center. So if you rotate it, it's not going to do that. It's going to do it from the center. This just calculates all of the, based on the attack render. So the position is always going to be different depending on the attack render. So it basically just sets all of the values depending on what it is. C0 and C1. Okay, yeah, C0 and C1 is basically for also for the border attack render. Because rotation, so this is basically all for the masking. So the mask will rotate with the border depending on if this is toggled to true or false. It just, you don't really need to worry about this. It just basically makes it so the mask moves with the border perfectly. So that's pretty much all that is. This part right here, this is how the collisions are handled, or how they're pretty much made. So if I go here and just boot up into the games, yeah, so these four walls are the collisions of the border. And this can basically, yeah, so it moves with the border. This uses I think it used to be called a pool array, but they changed it to packed vector 2 array, which okay. But so it takes all of the necessary positions where the collision should be, and it just maps it to this array, and then it sets the collision to that, which is pretty simple. So it's hopefully that makes it a little more optimized, and you can obviously kind of change the points to how you'd like it to within the border script. So that's how that works. Oh yeah, and then one more thing. There is a signal called finished that gets emitted when the border is done sizing. So let's see, finish.emit. So this is basically saying, if the position now equals the new position, it's just gonna emit this. So you can basically see this from other scripts and just wait for it to be finished if that's what you want to. This is used in I think when an attack is finished, I want to say, it'll wait for it to finish before displaying the text and allowing you to move around the menu. Okay, moving on to the next part, which is the soul. which is also found within the border. So in the soul, it's pretty simple. It just has a hitbox collision here, and then the regular collision for the border, so it can collide with walls and whatnot. Sprite is also pretty simple. It's just Undertale Soul. It has the flea in it, so you can just use that in the engine. Let me put this back. Okay, Soul script. There's a lot of you're probably going to see a lot of Toby code throughout some of these scripts for accuracy. It was not fun having to go through the original files on GitHub, the decompiled files on GitHub. That was not fun. But yeah, basically, this one's also pretty simple. It just has a mode and a speed. So the mode, I haven't implemented other soul modes. I'm hoping to do that, but I'm not entirely sure. I think I'll just release it as is. But yeah, so 1 is red, 2 is blue, and then 0 is basically just only used for the menu, but it's a variant of 1, just you can't really move around and stuff. The speed is also pretty obvious. This is the soul speed. You can change it however you want. The previous engine I was using didn't really have a variable where you could set the speed, and you'd have to, every single time I wanted to change it in a different game I was working on, I'd have to basically configure it and set the speed, like make a variable manually, and that was kind of annoying, so I just added it here. So yeah, and then these are all the values you don't really need to worry about. So yeah, the process function using physics process, like the border. This just gets the vector2 input, just returns a value based on what you press. It's set to an integer, and that kind of stuff. Cancel, this divider is just for when you hold X, it makes you slower. You can remove this if you want. I don't think this was in the original Undertale, but it is in most fan games now, so I just kind of implemented it. This is for the menu, just makes vector, or just return, oh my god. This just makes the velocity equal vector2.0, so you don't move. This is for the red soul, pretty simple. It takes the input vector, multiplies it by the speed, and divides it by the cancel divider. So here, this is the this is the not fun part that I can just barely explain. This pretty much takes the rotation of the sprite to handle like the up, down, left, and right blue soul mode. And then that's actually here. The jump input equals false. So yeah, this will set, I guess, a variable here. Actually, I'll keep that like that is. Yeah, this will just set the fall speed to the jump force depending on it. This is the part that is interesting to me. A bunch of else if and else if statements that determines the fall speed. That's just for accuracy. And then all of these are all just basically saying, like this one's saying if you're basically, okay, so it sets the jump input to up, meaning, and it does that in each one, which is basically which direction you have to press to jump. On ground is set to also according to the side of the border you're on. These ones are a little more confusing because on ground doesn't work in Godot 4.4, unfortunately, for being on the sides, which I mean, I guess that kind of does make sense, but I mean, that's pretty much all that does. Jump direction also sets it to a vector2 value. This basically just says if you're on the ground, you can jump, if jump input. So yeah, if you're basically pressing the jump button, it'll set your fall speed to the jump force, which fall speed is, jump force is basically inverted. So instead of going towards the ground, you just go away from it. So that's what this does. It sets your fall speed to 0 before doing that, which, or that's just if you're on the ground. So it doesn't infinitely change. So for example, like if you were to fall onto a platform, I think this is set to 0 anyways, but yeah, it definitely is. But if this weren't here, you'd basically be falling infinitely, and the velocity would keep going up and up and up, and then you'd basically probably clip through the boxers or break the game or something. Definitely don't want that. Um, this is just for when you in air is called or is set to true when the slam function is called. I can't remember if it's called that or not, but it'll set it to true, and then when you hit the ground, it'll detect it, and then it'll just do this. So you can set that to whatever you like. You can get rid of the camera shake or make it really aggressive. Do whatever you want with that. Okay, this is basically setting a cap to the fall speed. I think this is for when you get to the top of the jump. I can't remember, right? But yeah, that should be what it is. This just tells you to move and slide, and this applies to all the modes. Okay, this is the block of code that determines collisions between bullets. So it basically checks the hitbox, the soul hitboxes, the areas that it's overlapping, and it checks if it's in a group called bullets, and if you're able to take damage, which is the iframes. So if that's found, it sets the bullet to the found.getParent. Found is the area that it finds, so getParent would be the bullet. So it basically checks for if there's a variable called damage in the bullet. If there is, then it basically calculates the damage here. And this also depends on if there's type in bullet, which type is 0, 1, and 2. So it would be white, blue, and then orange. So blue, if you're obviously not moving, you won't take damage, and orange, if you are, you won't. That's all calculated here. And if there's no type, then it just sets it to the damage. And then this is the function take damage, where it just basically makes the soul take damage. The reason why it's in a function is because you can call it from other scripts if you want the soul to take damage. I mean, you could set the HP manually, which would still work, but this is just if you want the animation and stuff to happen, and the sound and whatnot. And then this little part here is just basically saying to add KR if there's a variable called KR damage in the bullet. Otherwise, it just puts in 0 and nothing happens. Previous position equals position. This is how this part is handled with the blue and the orange bone. It's how it basically takes the checks the position of the last frame and the current frame, and gets the normalized vector of this, and checks if it is equal to or not equal to 0. This is basically for the iframes. It just says if iframes is greater than 0, then kind of subtract it so that and subtract it and play the sprite. So it only does it for a certain amount of time. This is set through the take damage script. Otherwise, it'll just turn it off if they're toggled. Damage time plus equal delta. This is just Toby code. Yeah, delay between hits. This is the entire KR system, which I just barely understand as well because I basically just took Toby's code. This clamps the KR because Undertale has it so that it can only like get to the value 40 and nothing more. And then it also clamps it too so that when you get to 1 HP, it'll not kill you instantly, pretty much. This part just says if this is so that you don't die if you're at 1 HP, and you can just kind of still see the KR thing. And if your KR is over than 0, KR doesn't work as doesn't work like HP as to where it's set to a value like 0 to 99 if you're level 19. It's set to it's always going to be kind of like a delta value, like probably a float, because of this section here. But first, I'll cover this. This entire spot basically just determines the bleed, the KR bleed. So when you take a bunch of damage and then you stop taking damage, it'll basically go fast and then slower and slower. You can see my very nice comment here, Toby Y. I mean, yeah, true. This subtracts the HP and the KR. KR is basically just going to be a value. I said it was a float earlier. Kind of true. It's just a value, 0 to 1 when it reaches this specific value, it's going to subtract with the amount of time, so that this is basically the bleed time. That part is super confusing. I might not have explained that very well, but it's okay. I don't understand either, and you don't really need to know how this works, I hope, because it's already implemented, and you don't really need to do much about it, hopefully. This part just clamps the HP to the max HP, so you can't. Oh, that's weird. Why is this at 1? Okay, wait, this should be 0. I don't know why that was 1. Because 0 would mean you die. Yeah, weird. Okay. Well, this basically just clamps it so that you can't go over or under 0, and you can't go over the max HP. Change mode. This, yeah, self-explanatory. Change the modes. Mode colors can be changed here in this match I guess switch statement, or match as it's called in Godot. Set the modulate of the soul here. So 0 and 1 is just menu and red soul, and then 2 is blue, obviously. This is saying if the mode is not equal to the menu mode, it'll play the bell sound. So this basically just makes it so that when you go from the attack back to the menu, it doesn't like play a random bell sound. That would be kind of weird. And then rotation degrees equals rot, or rotation. So that's also pretty straightforward. If you set this to 90, it'll be detected up here and here, and then it'll do all the blue soul logic depending on the rotation. So the rotation does depend on the sprite's rotation instead of the node itself. So I guess just remember that it's all dependent on the sprite's rotation rather than the soul if you're going to modify it. Throw is also pretty easy. The vector is basically vector up, down, left, and right. Basically which direction you're thrown. In the previous engine I was using, this was handled with like 1 through 3, or no, not 1 through 3, 0 through 3, which was super confusing because I never knew which one was up, down, left, and right. So I basically made it vector, like a vector value instead. So that's a lot easier, I think. Honestly, I'm gonna add this here, vector 2 dot down. So if you want to throw them at the floor, you could just do throw, and then that's it. And then speed, which is the speed that they're thrown at, I just set it to 700. You could do whatever. So yep, there we go. Throw. Take damage. Yeah. Okay. Yeah, this is important. If KR is -1, it's inactive. I kind of want to go over this later, but I could just cover it really quick. Right here in the global script, KR equals 0. Yeah, it says it here as well. -1 makes the KR completely inactive, and the soul will use iframes instead. So that's just a small configuration thing that you can keep in mind. This basically says if damage equals 0, return, because sometimes the function is called when it equals 0. Damage time this is just basically saying, this basically makes it so that when you touch a bullet, you don't just instantly die. So it just has that little delay in between, so you take damage at a consistent rate. And then if it is consistent, then it sets it to 0 again, and then this gets added plus equals delta times whatever, and then it'll eventually go to this again. The reason why it's 1.0 divided by 30.0, I actually don't know why this is here, but I think it's just another Toby code thing, and I'm kind of scared to mess with that. So if iframes is less than or equal to 0, so if you can take damage and you don't have invincibility frames, then subtract the damage, or subtract damage from the HP. If there's KR, then add the KR. Otherwise, it'll just do the iframe thing. This is just detecting whether KR is enabled or not. Then it'll just play the audio. So that should be it for the soul. There is something in the engine itself which is a little confusing, called toggle soul index, but I'll cover that later. It's specifically made for the engine, so yeah, you'll see that later on. And then that's it for the soul section. I guess now I'll be covering the autoload global utility and audio scripts, which all three of those are just basically I mean, utility is called utility because it's, utility functions, or for the engine. Um, but these are all kind of utility things.